Alright, welcome back to the SciMax channel. Today I'm going to look at OpenCode. This is an open source version of a coding agent similar to what I've been using with Claude Code, but it is not connected to Anthropic or OpenAI or Gemini. You can use lots of different providers over here, DeepSeek or Grok or Copilot, something like that. I'm going to keep using it with the Anthropic model, but it's easy to install. You have all of these options. I run a Mac, so it's brew install code, OpenCode, but you can also use a curl command. And what I want to do today is use it to convert the Python file that we generated yesterday for this optimization of a complex evaporator into a Julia file. Julia is a newish scientific programming language. It is supposed to be very fast, and I mostly am just interested in seeing how this conversion works. I want to change my model here. Let's use the Sonnet 4.5. I've used this for many things and feel pretty comfortable with it, but let's just see what we have here. And what we're going to do is convert evaporator underscore optimization .py into a Julia file. Now there's a bunch of reasons you might want to do this. One is you might be familiar with Julia and want that as a starting point. Another might be that it is too slow in Python and it is an easy way to get a speed up if you just write it in Julia. That was one of the reasons Julia was made. Another might be you want to learn how to solve problems in Julia. Julia has different libraries, different capabilities, and may have something that's more suited. Whatever the reason is, it's maybe just fun to try and see. Now, this is a translation activity. It should be something that LLMs are good at, and we will see if we can actually get a Julia file and then run it. Now, a couple of things that look different. This is roughly the same feel of typing interactive prompts and then watching, do something here. Up in the right, it does show you, what our context and tokens are. We're at 6%. When this gets to 100 in Claude Code, it does something called compacting. I don't know what it's going to do here. Here it gives you, some idea. We're up to 16 cents, and it looks like we already have a Julia script that's been generated. It talks about some differences. It is saved as evaporator optimization.jl. Let's have a look. It is in fact there. And now it's easy to generate things that look like Julia, but we should try to run it. So let's see what happens. I'm not a Julia expert, so I assume it's something like, a command line Julia, maybe some flags and a file. So we try to run it, and here we see I don't even have Julia installed, and so we're not able to do that. Let me just say, help me install it. So this is not a super bold choice. I could follow those directions, but here I'm going to let OpenCode find Julia, install it via Homebrew. I trust Homebrew, so that's okay. It's not finding totally random things. So here we are installing Julia. We're up to 23 cents now, according to that. It's a good question of how much is it worth to be able to do this. I wouldn't be able to translate this into Julia very quickly. Maybe it would take a day or two because I would have to learn a lot of Julia syntax. There's differences. Python is 0 indexed, Julia is 1 indexed. I'm sure I would make a ton of mistakes. Even working from an existing working Python file, I think it would be quite a challenge to do that. Alright, so we have packages that got installed. It's going to run this. It looks like we might have a syntax error, and this is why we wanted to run it. And so it went ahead and fixed that for me. Now it's running it again. Here it looks like it's generating some output. So let's see if I can just copy this. Maybe not. Oh, doesn't highlight it. That's interesting. So it's solving it. Looks like we get to iterations. This looks okay. Optimal solution found. Here we compare what we found to what was in the previous table. We get exactly the same result. There is a warning here about a constraint violated, and it says there's only one active constraint, but otherwise it says that it has worked and it got to the same answer. So let's see what happens over here. Python. So this one says we should have two active constraints, x2 and p100. Julia, evaporator optimization.jl. This should give us, it's going to give us basically the same result. And if you look here, this is the P100. This is where the possible issue is that this, even though these say 400 and 400 within tolerance, we have minus 4e minus 6. And so it's not recognizing this, even though this, if you remember, P100 can only go up to 400. And here it goes maybe a teeny tiny bit over it, but that's a tolerance issue. So we have to apply some engineering judgment and understanding on that. Otherwise, this looks pretty interesting. It cost me 34 cents and a little over 7 minutes to get a working Julia file, including installing Julia and the packages, and to be able to run it. Maybe since this was so fast, let's ask it to install the Julia Jupyter kernel. And then convert the Julia script into a Julia Jupyter notebook. And maybe let's see if what happens if I ask it to open the Julia notebook. Similar to yesterday, I find it convenient to go through the script interface to get a working solution because the CLI tools are so good at running a script that is text-based, getting output that is text-based, and iterating through debugs. And I find it less convenient to do that through the notebook interface, at least in this style of work. If you're using something like GitHub Copilot, integrated into a notebook, it might be different. Let's see if this works. You can see we've got a Julia kernel up here. You see Julia up here. This is not so surprising. In the past, when I've used Julia, the first time you run things can be very slow. This seems unusually slow. But sometimes it is building packages, compiling packages. I don't know why this is as slow as it is. Let's see what's up here. It's connecting. Let's make sure that I didn't pay close attention. It does say it's available. Alright, so it looks like that should have worked, but we are kind of stuck in this connecting mode. Let's see if we can just restart and run. Oh, look at this. I haven't seen this little, oh, you can't see it. There's an interesting little sidebar over here. Let's see. Okay, failed to fetch. Let's see what this says. Oh, there we go. Let's see. Seemed like it worked, but now it's connecting. Let's see. Let's see if that made any difference. No. I guess we're flying too close to the sun here. All right. That looked okay. All right, I guess we're back to working. Let's see. Got everything going there. Analyze the results and extract the answer. Okay, great. So just under 14 minutes and under $1, we have a working Julia installation, a translated script, and a Jupyter notebook that we can explore and use. So that's it for this video. The whole point again is that we can use these coding agents for a large number of things. We can solve problems like I did yesterday. We can take existing solutions, transform them into new languages like Julia, and even get help setting up a Julia environment that we can use in Jupyter Lab. Pretty straightforward. All right, thanks for coming, and see you next time.